So assuming that you know about the pathophysiology of autosclerosis, let us start about carhart's notch. So carhart's notch, it is a finding which is seen in the Pearson audiometry graph of autosclerosis. What happens in this graph? We see that there is a dip which is seen at 2000 Hz in the bone conduction curve of Pearson audiometry graph of autosclerosis. We all know that autosclerosis, it is a type of conductive hearing loss. It is a conductive hearing loss. So what are the findings that should be seen in case of a Pearson audiometry graph? The air conduction should be abnormal, the bone conduction should be normal, and the air-bone gap of more than 20 decibels should be seen. So let us see what is happening in the graph of autosclerosis. Air conduction curve that is depicted by a continuous line, and because we are depicting the X here, so it is of the left ear, and we see that the air conduction curve is falling below 20 decibels. Below 20 decibels, so it is abnormal. What about the AB gap? Yes, we are seeing a AB gap of more than 20 decibels. This graph is showing a AB gap of around 40 decibels. So yes, there is an AB gap. What about the bone conduction curve? The bone conduction, maximum part of bone conduction is falling within 20 decibels, but only one part of it, that is at the corresponding to the frequency of 2000 Hz, it is falling below 20 decibels. So what should be the question that should be coming in our minds is, although autosclerosis is a conductive hearing loss and there should be an abnormality that should be seen in the air conduction curve, but here bone conduction is also altered. It is not completely normal, it is altered here. That is showing a dip at 2000 Hz. So our first question is, why a dip is seen in bone conduction? So answering this question, we should know what is bone conduction and what are the pathways of bone conduction. So bone conduction is a type of sound conduction which occurs directly by the vibration of the skull bones. So it has three pathways. One is direct vibration of the skull. Suppose we are giving a vibration at the level of mastoid and the vibration is spreading. The vibration is spreading to reach the cochlea. This is the first pathway which directly stimulates the cochlea. Second is the vibration of the ossicular chain. So by stimulation of the mastoid, by stimulation of the bone, the ossicles are also a part of the bone. So there is also vibration of the ossicles which then reaches to the cochlea. This is the second pathway. And the third pathway is the vibration of the external auditory canal. So we are not talking about the air conduction which involves the vibration of the sound, the vibration of the air from the external auditory canal and then passing on into the ear ossicles. We are about the bony part of the external auditory canal which is getting vibrated and then it is transferring the sound vibrations to the ossicular chain and then to the cochlea. So vibration of the bony external auditory canal to the ossicles and then to the bony labyrinth. It is part of the skull involving the bones only. So three pathways. One is involving directly the vibration of the skull then to the cochlea, then vibration of the ossicular chain to the cochlea, and then vibration of the bony part of the external auditory canal, and then the ossicular chain, and then the cochlea. So now we understand that autosclerosis, the pathophysiology of autosclerosis involves spongy bone formation of the footplate of stapes, because of which the vibration of the ossicular chain is affected because the footplate of stapes is now fixed. So vibration of ossicular chain is affected. So the second and third pathway which is involving the ossicular chain is getting affected of bone conduction. So that is why we now understand that why there is a affected bone conduction curve in autosclerosis, because the ossicular chain which is a part of the bone conduction pathway is getting affected here. Therefore the bone conduction curve is affected. Now answering part 2 of the question, where why there is a dip particularly at 2000 Hz only. If the bone conduction should be affected, then why not the whole part of the bone conduction and only the 2000 Hz of the bone conduction where that is only affected. So before understanding that, we should know about resonant frequency. So what is resonant frequency? Resonant frequency, it is a frequency at which the system vibrates at maximum intensity. So whenever we give a frequency of sound, we are actually giving vibrations. So at particular frequencies, the particular part of bone will vibrate. We see that resonant frequency of ossicular chain for air conduction pathway is around 800 to 1200 Hz. And for bone conduction pathway, it is around 1600 to 1700 Hz. So for bone conduction of the ossicular chain, the resonant frequency of ossicular chain is around 1600 to 7000 Hz. That means at this particular frequency, the ossicular chain will be vibrating. And because vibration at this particular frequency is affected, so at this particular frequency, a dip will be seen in the curve. And you guys will ask, why there is a dip seen in 2000 and not 1600 to 700 Hz? Actually, we are not measuring the 1600 and 1700 Hz value in a Pearson audiometry curve, and the nearest value is 2000 Hz. So at 2000 Hz around, we are seeing a dip at the Pearson audiometry curve. Hope it helps. Thank you.